Every second, modern organizational networks are flooded with spreadsheets, emails, and database exports. It is a massive, chaotic stream of unstructured data. If we stopped to manually evaluate the risk of every single interaction, our systems would grind to a halt. It is mathematically impossible to treat every file as a unique security case. To solve this bottleneck, we rely on data classification. By grouping information into a small number of meaningful categories, define standard handling behaviors without needing a constant manual review. Classification is the architectural decision. It determines exactly how sensitive a piece of data is and what level of protection it requires. Labeling is merely the communication mechanism. It is the visible mark or digital tag that broadcasts that classification decision to users and systems. This diagram illustrates how the internal decision-making process works. The logic separates from the metadata tag. The classification decision is distinct from the label that broadcasts it. A label is entirely meaningless unless it is tightly coupled to explicit behavioral handling rules. This diagram outlines the 4 baseline protection zones organizations use to categorize their information: public, internal, confidential, and restricted. Internal data acts as the baseline zone. It covers routine operations that are not meant for public release, but would cause limited harm if exposed. Moving inward, the confidential and restricted zones cover high-risk information. These tiers demand strict need-to-know access, active control mechanisms, and formal sharing approvals. There is a common assumption in the industry that classification exists solely to maintain secrecy. That misses the larger operational picture. Take a look at the public zone here. Public data does not mean unprotected data. It requires stringent safeguards for integrity, authenticity, and availability. Consider an official exam schedule or an emergency alert. While they require zero confidentiality, they require absolute accuracy. If an attacker alters that schedule, the issue is not exposed secrets. The result is severe operational disruption and immediate reputational damage. Effective classification matches the protection to the specific type of impact, whether that impact is a breach of privacy, a loss of trust, or a total system failure. It is dangerous to assume that data sensitivity is locked into a specific file format. Sensitivity shifts dynamically. This diagram shows a single row of data, a student ID and name, locked with an internal tag. On its own, this poses minimal risk, but watch what happens through aggregation. Combining separate, low-risk pieces of information geometrically increases the overall meaning. The required protection immediately upgrades to confidential. Standard operational data behaves the same way. Attaching travel dates and access privileges to a public job title creates an immediate security vulnerability. We also have to account for inference. This scatterplot represents small group analytics. By examining the surrounding context, bad actors can deduce unstated sensitive facts and reverse engineer an individual's identity. Stripping out direct identifiers like names and ID numbers does not eliminate the risk if the remaining data pool is small enough to single someone out. A classification decision must evaluate the entirety of the information set, not just the lowest risk individual field. Because context dictates sensitivity, static labels will fail to protect dynamic datasets if they are not actively reviewed. This pipeline illustrates how we operationalize labels across the lifecycle. A file marked confidential requires explicit handling rules at every stage. At the storage node, delabel dictates approved locations and restricts the data from entering unmanaged environments, like a personal cloud account. Use rules then connect access directly to an employee's role. Viewing the data requires an approved, legitimate business purpose. When users repurpose data for reasons entirely separate from its original intent out of simple convenience, they create purpose drift. Sharing rules introduce necessary friction. When data attempts to cross organizational boundaries or move to third-party vendors, the rules demand formal approval. Finally, disposal rules are frequently bypassed. Users delete the primary source file, while ignoring the local downloads, backups, and synced cloud folders that still house the sensitive information. Handling rules are the actual architectural controls protecting the data. Without them, classification is merely bureaucratic decoration. This balance scale demonstrates how classification systems critically fail when labels do not accurately reflect the real-world sensitivity of the information. When information is underclassified, systems enforce weak access controls and permit rampant oversharing. The inevitable result is exposure. Conversely, overclassifying data, like stamping a public event flyer as confidential, slows legitimate work and actively encourages users to build unsafe workarounds. Another major vulnerability occurs when files are generated or exported without any explicit sensitivity tags at all. Unlabeled organizational data must never default to public. It snaps to a balanced engineering baseline, default internal. That unlabeled file must be treated as internal data until the information owner explicitly verifies its actual sensitivity. Labeling everything restricted breeds user fatigue, while treating unlabeled data as public guarantees a breach. True security requires proportional precision. Data classification brings necessary structure to professional judgment. It translates the intrinsic value of your data into predictable, everyday behavior. Because that value shifts over time, organizations must maintain active governance, reviewing and reclassifying information as its context changes. Zooming out from the lifecycle pipeline, we move from conceptual classification to applied security, connecting directly to access control. Classification identifies data sensitivity and who theoretically needs it. It serves as the foundational blueprint, making actual control mechanisms possible. By categorizing data and strictly enforcing handling rules, we generate the operational parameters required to deploy precise, role-based access controls across the organization.